The opinions expressed by ResusLogix or Dr. Montano do not necessarily reflect the views or positions of his employer, past or present.
All right, welcome everyone. You know, in critical care, sometimes the questions we face every single day are actually the most complicated. And today, we're going to tackle one of those, one that seems so simple but is just packed with controversy.
I mean, think about it. Our instinct, right, as clinicians, heck, just as people, you see a fever, you want to treat it. You see that high number on the thermometer, and your first thought is, let's get some meds from cooling, let's bring that number down. But here's the kicker. What if, in the critical setting of sepsis, that instinct is completely wrong?
Okay, before we really get into the weeds, just look at this number. 47.3%. That is the mortality rate for septic patients who are hypothermic, the ones who are too cold. I mean, wow. That right there tells you just how critical temperature is and that the danger isn't just about being too hot.
So, to figure this whole thing out, we're going to put on our detective hats, we're going to follow the evidence, and we'll be using a fantastic 2023 review by Doman and colleagues as our guide. It's kind of like a journal club, really. Here's how we're going to break it down.
Okay, so first things first. Let's frame the central question, the core conflict, right? Is fever a friend or a foe? Is it this amazing adaptive defense mechanism that our bodies have perfected? Or is it just a dangerous symptom we need to stamp out before it does real damage?
And to answer that, we have to be super clear on what a fever is. And it's not just being hot. It's a really deliberate, controlled process. Think of it like this. Your body's thermostat, the hypothalamus, intentionally turns up the heat. This is so different from something like heat stroke, which is just hyperthermia, where the body's cooling system is totally overwhelmed and breaks down. All right, so if we're going to dig into the research to find a real answer, we've got to ask the right question. You can't just go in blindly. And in medicine, the PICO framework, it's the perfect tool for this. It helps us break down a huge, messy question into clean, answerable parts.
So here's how it works for our question. The P is our patient, adults with sepsis, simple enough. The I is the intervention. What are we doing? We're actively trying to control their temperature, with paracetamol, cooling blankets, the whole deal. C is the comparison group. What are we comparing that to? Well, to a group where we do nothing, no active temperature control, maybe a placebo. And finally, O, the big one, the outcome. What are we measuring? Survival. At the end of the day, that's what really matters.
Okay, let's start with the case for fever. Let's call this the defenses argument. Why might a fever actually be a good thing, an ally during sepsis? Well, it turns out there's a ton of evolutionary biology that's got fevers back.
And it's honestly pretty amazing when you look at all the ways a higher body temp can help us fight. For one, it can literally slow down how fast some bacteria can multiply. It can make our antibiotics more effective. It triggers these things called heat shock proteins that protect our own cells from damage. And it basically puts our immune system, our little neutrophil warriors, into overdrive. Pretty cool, right?
But it's never that simple, is it? Now we have to hear from the prosecution. What's the case against fever? Because there are some really scary, potentially dangerous downsides to letting a fever just run wild, especially when a patient is already critically ill.
And this slide just lays out the dilemma perfectly. On the one hand, the prosecution's case. Fever jacks up the body's metabolism, it demands more oxygen, which can be an absolute disaster when your organs are already on the brink. We're talking tachycardia, dropping blood pressure, real organ damage. But then you have the defenses argument. It's this powerful natural tool for fighting infection. It's a total biological tightrope walk.
So, you've got strong arguments on both sides of the aisle. Where do we go from here? Well, we go to the highest court in the land of evidence-based medicine, randomized controlled trials. This is where we get the verdict. So, what did they find? And people have put this to the test in a big way. We're talking major trials, like the famous HEAT trial. They took thousands of septic patients in the ICU and randomly assigned them to one of two groups. One gets active fever treatment, like paracetamol, and the other gets a placebo. It's the ultimate head-to-head comparison to see if what we do actually makes a difference. And the results, well, they're not ambiguous. They are stunningly clear. When you take all the data from all these big trials and pool it together in a meta-analysis, there is no significant benefit to treating the fever. Whether you use drugs or physical cooling, it just doesn't seem to save more lives. The relative risk is basically 1.0, which is statisticians speak for it made no difference.
And look at this quote. This is from a huge meta-analysis in the BMJ, so it's top-tier evidence. They said the hypothesis that antipyretic therapy reduces the risk of death could be rejected. I mean, that's about as blunt as scientists get. We can confidently say that the thing we've been doing for years probably doesn't help.
So the verdict is in. Our routine practice of jumping on every fever in a septic patient, it's just not backed by the evidence. And here's where it gets even more serious. It's not just that it doesn't help. If we get too aggressive, if we push that temperature too low and make the patient hypothermic, we might actually be harming them. The data suggests it can lead to worse outcomes. Okay, so enough with the trials and the theory. What does this actually mean for us at the bedside with a real patient in front of us? Let's take all this evidence, all this great stuff from the Doman review, and boil it down to some simple, practical guidance.
And here it is, the bottom line. The evidence is pointing us toward a much more nuanced and, frankly, a more hands-off approach. If the fever is mild or moderate, the best thing to do is probably nothing. Just observe. Now, if it gets really high, say over 39.5 Celsius, then yeah, it's reasonable to think about gently bringing it down. But, and this is a huge but, you have to avoid shivering at all costs. Shivering just skyrockets their oxygen demand. And on the flip side, for those patients who are cold, we need to be actively rewarming them, but slowly and carefully.
And just to leave you with something to chew on, there's some really wild new research coming out that links our fever response to the bacteria living in our gut, our microbiome. So it really makes you wonder, right? Maybe in the future, how we treat a fever won't be a one-size-fits-all rule, but could be totally personalized based on, well, who knows what. It's a cool thought as the science keeps moving forward.